Happy morning, dear friends. Here's yours, Dr. Rajitha. Welcome to day 23 session. Today we are just going to see about Python sets operation. Sets can be used to carry out mathematical set operations like union, intersection, difference, and symmetric difference. We can do this with operators or methods. And see here, dear friends, let me just consider the following two sets for the following operations. A is equal to 1, 2, 3, 4, 5, and B has the set of 4, 5, 6, 7, 8. When I'm just making the union operation, that is union of A and B, is a set of all elements from both sets, and union here, how the exact performance is by using an operator like this. Okay, so same can be accomplished by using the union method, where we can just make use of that in example 2. Okay, let me just see by the example 1 by using the set union method. See here, dear friends, here we are just having A is equal to 1, 2, 3, 4, 5 and B is equal to 4, 5, 6, 7 and 8. When I'm just using the operator, say print A, and here it is a bar operator, and where when making it on union, so A union B, so combining both the elements, both the items. Okay, here how the exact output would be is combining both the things, that is 1, 2, 3, 4, 5, 6, 7 and 8. So here the duplicate won't be repeated, only the unique values has been done. And let us just execute it, dear friends. See here, we just have the exact output. And next comes the uh, example with using union method. And see here, dear friends, here when I'm just making use of union function A dot union B, that is it combines 1, 2, 3, 4 from A, sorry, 4, 5 from A and 4, 5, 6, 7, 8 from B, whole to that of union. And even though you can just make use of B dot union of A, both would be the same output only, whereas it just been combining A and B. That's it. Okay, next going for a set interaction, intersection. And see here, dear friends, intersection of A and B is a set of elements that are common in both the sets. That is, intersection is performed using ampersand operator. Same can be accomplished using the interaction method. Let me just first see with the ampersand operator. A is equal to 1, 2, 3, 4 and 5, whereas B has the element of 4, 5, 6, 7 and 8. And when combining the both, the intersection of sets A and B were common for the both the sets. We are just want to execute it by using the common print function, print A ampersand B, and here our resultant would be executed as 4, 5, where 4 and 5 would be the common for both the sets. And see here, next by using the intersection method, to the same here, A dot intersection B or B dot A intersection of A, both the things would be resulted to the same 4, 5. Let me just move on to the set difference. And see here, dear friends, when coming to the difference, here we just have a differentiation rather than this union and intersection. Yeah, kindly have a note of this, dear friend. Difference of the set B from set A. Okay, so that is what has given in this exact diagram. And A minus B is a set of elements that are only in A but not in B. And similarly, B minus A is a set of elements in B but not in A. So difference in performing using this subtraction operator, same can be accomplished by using difference method. And kindly have a note of this, dear friend, it won't be the same as the union or intersection. Here, see here, when on just making use of the operator, that is the subtraction, that is the minus, see A is equal to 1, 2, 3, 4, 5 and B we are just having the element as 4, 5, 6, 7 and 8. When We are just want to know the difference of A minus B, that is there in A but not in B. There in A but not in B. There is no, both the things it is common for 4 and 5. So removing the 4 and 5, or we can just eliminating the 4 and 5, the remaining elements would be the difference between A and B. And when just making the B minus A, it is not same as N minus B. So where it should be in B but not in A. So as in B, 4 and 5 is already there in A. So eliminating that 4 and 5 of repetition, here the exact answer would be 6, 7 and 8. Okay, let me just see it with the difference method. Okay, and see here, dear friends, when I'm just making A dot difference of B and B dot difference of A, the exact above resultant would be the appeared here also. Okay, and let me just see the next operation, set symmetric difference. See, symmetric difference of A and B is a set of elements in A and B but not in both, that is excluding the intersection. So symmetric difference is performed by using that power operation. Okay, so same can be accumulated by using the method as symmetric difference too. Okay, let me just make use of that operator first and see here, dear friends, in the example 1, A to the power of B, and when I'm just making here, see 1, 2 and 3 is not in B, and 6, 7, 8 it's not in A, that is in B but not in A. So combining the both, that is eliminating only the difference, we would just get the symmetric difference of these two sets. And when I'm just making use of the function symmetric difference, yeah, we would just result out with the same output as the above 1, 2, 3, 6, 7 and 8. And dear friends, kindly have a look of this, that there are many set methods, some of which we have already used above. Here it is the list of all the methods that would be just used for the other set of operations. One is we can test if an item exists in a set using the in keyword. Okay, so that is said to be the set membership test. And see here, dear friends, when I'm just making use of the exact element in my set. Okay, and the element of the my set is apple. Okay, and I just want to check whether A is present in the set, my set. Okay, so here how I am just making it A in my set variable, and to the same we can also make use of not in also, and P not in my set. And when on resulting to that, whether it is present or not, the resultant would be a boolean thing, whether if it is present, yeah, it is true, and if it is not present or not in, or if it is the exact to that of opposite of making the not available, so it just provide the false as the resultant. And next coming the iterating through a set. Iterating through a set, actually here the for loop it just comes, so let me just eliminate it by making it, and we would just discuss it in later coming sessions. Next comes the Python Frozenset. And dear friends, kindly have a note of this. This Frozenset is a new class that has the characteristic of a set, but its elements cannot be changed once assigned. While tuples are immutable lists, frozen sets are immutable sets. And see here, dear friends, sets being mutable or unhashable, so they can't be used as dictionary keys. On the other hand, frozens are hashable and can be used as keys to a dictionary. And frozen set can be used created by using these frozen set functions. Okay, so this frozen set function returns a immutable frozen set object initialized with elements from the given iterable, and this data type supports methods like copy, different, intersection, is disjoint, is subset, is superset, symmetric difference, and union. And here the exact syntax of the frozen set iterable, kindly have a note of this, dear friends. Let me just see it with an example. That is, A is equal to frozen set of 1, 2, 3, and 4, and B is a frozen set of 3, 4, 5, and 6. And see here, we are just initializing the element of A and B. We're not just making the disjoint, that is, they have common intersection point. And when we just check whether they are having any common intersection point, no, they are just not having any common intersection. So that reasons as false. And when coming to the A difference of B, and see here, dear friends, it should be in A but not in B. So here 1 and 2 is the exact frozen set that just resulted with A difference B. And there comes the next one is union. Okay, combining A and B, so that here we are just receiving the frozen set of common to that of both combining to that of both, where A and B. Okay, so the elements are 1, 2, 3, 4, and 5, 6. Okay, and see here, dear friends, we can't include any of the value by using add, because add is not an attribute of this set, so it results with an error. Fine. When coming to the methods of frozen set, there are data types that supports like copy, union, intersection, difference, symmetric difference are the exact data types that supports this frozen set method. And being immutable, it does not have methods that add or remove element, as we have already seen it. Okay, and kindly have a note, A is equal to 1, 2, 3, and 4, and B we are just having the frozen set of 3, 4, 5, and 6. When on making the copying in the sense, we want to make a copy of one of the frozen set. And see here, dear friends, actually C is the copy of A. When we just want to know what is there in C as a resultant of a copy of A, all the elements from the A, it would be copied and specified as the frozen set of C. Okay, and next, when coming to union, yeah, it is the combination, or that is concatenation of all elements from A and B, and here we are just want to execute A dot union of B by using the union method. And the next one, the intersection method, where it is just resulted with the common from the frozen set A and frozen set B. And there next, the difference of A dot difference B, that is, it should be there in A but not in B. That is what the difference. And when coming to symmetry difference, that which is the common thing should not be there, common to the both frozen set, it should not be there. So that is what here it is specified. And when on executing, yeah, see, kindly have a note of this. The first one is copy of A, and it is assigned as the variable C. And next one, union of A and B, and the next intersection of A and B, difference within A and B, and the last one is symmetric difference. And last but not least, see here, dear friends, let me just have the other frozen methods also, where the methods which we can just make use of is disjoint, is subset, and is superset. And to the same, see here, dear friends, we have initializing A, B, and C, where A has the frozen set of 1, 2, 3, and 4, and B, we are just having the frozen set of 3, 4, 5, 6, and C, the frozen set of the element 5 and 6. When just making the disjoint of C, yeah, exactly, nothing, we are just having the common between A and C, so it results with true. And see here, dear friends, when making C is a subset of B, exactly, see the element of the C is one among the subset of B, so yeah, that is also results with true. And see here, dear friends, B is superset of C, exactly, the set of element in the C, not only that, some other elements also that is present in B, so which it just says to be yes superset. So yeah, and it is verifying is superset and it is resulted with the true. And dear friends, here I have just provided some exercise for set level 1, level 2 and level 3, and kindly have hands on with this exercise. Thank you, dear.